Good morning. This is the lesson on the muscular system for Plateau Valley Ag Program Animal and Vet Science class. The function of the muscular system in animal science is to provide movement with the skeletal system and also to provide a food product for human consumption. The muscular system is obviously vital for human support, or for life support in the animal, rather. Without muscle, the skeletal system can't do much on its own, and vice versa. Without the skeletal system, the muscular system can't do much on its own either. We do a lot of research on the muscular system in animals, specifically one muscle at a time, but most of it is leaning towards how we use it as a food product. So that's an important attribute to remember, is that in many farm animals, because agricultural production has to be an enterprise that makes a profit for it to continue, sometimes that research is confined by what makes money. When we classify muscles in animals, and this goes for humans as well, we typically classify them as voluntary and involuntary. A voluntary muscle is the muscles I engage if I reach my arm out and punch you in the nose. I thought about that, I controlled my muscles, and I punched you in the nose. An involuntary muscle movement is a muscle movement that happens that I have no control over. So the easiest connection for people to make is probably that when you're sitting on the bench in a doctor's office and they tap your knee with the little hammer and your leg involuntarily kicks. That is involuntary muscle movement. Those are both human examples. If you then switch this to the animals that we've been studying, voluntary muscle movement is typically what's going to happen when the animal is moving away out of fear or towards food or water, something like that. Involuntary can include both the things that are happening to the animal when they're not paying attention, like their lungs and heart beating and breathing, as well as the things that happen as reflexes. This is probably the most important slide for you to put in your notes, so feel free to pause it and record things as long as possible, or as long as you need, rather. We classify all muscles into three types: smooth muscles, cardiac muscles, and skeletal muscles. As you may have guessed, the vast majority of muscles in an animal's body are skeletal muscles. These are also the majority of the muscles that we consume as food. Smooth muscles, however, are much more vital to the workings of the animal system. Smooth muscles are usually involuntary, and they're found inside the walls of internal organs, blood vessels, and things like that. So when you look at the systems that keep a body alive involuntarily, the muscle that exists within those is smooth. You can see in the top right-hand corner of the slide that there's a picture of smooth muscle fibers, and you can see that they are relatively smooth, which is how they got their name. Cardiac muscles are the second major category. Cardiac muscles really are confined to just the heart. This is important to note because of all the muscles in your body, the heart is probably the toughest and also most important muscle. Some people argue that maybe the brain, which is also a muscle, is more important than the heart, but I'll leave that for you to argue on your own. When we look at the cardiac muscles under a microscope, like you can see in this picture, they have a little different appearance than a smooth muscle. The cardiac muscles are a little bit more fibrous, if you will, and that leads to them also being a little bit stronger and under constant work. And then finally, at the bottom of this screen, you see skeletal muscles. Skeletal muscles are always easier to recognize under a microscope because of the striped appearance that you can see in that picture. Skeletal muscles can be both voluntary and involuntary. And the big deal about skeletal muscles is they're almost always attached to a bone, which is how they get their name. The majority of the muscle tissue in your body and in animals' bodies are skeletal muscles. Now, we talked in class last week about how when we synthesize this idea of muscle and muscle use and lean it more towards then what food products are, the bigger the muscle use, the bigger the muscle is. And so as we divide those muscles into the front limb and the hind limb, we actually find that those muscles in the front limb get quite a lot more use. They attach the front legs of a four-legged animal to the body, pretty fan shaped. But the thing that gives them kind of that high use is that it supports the trunk of the body between the legs. And this is something different than in human beings because most of you don't walk on four legs, rather you walk on two. So when you think about a carcass, we talked about then processing a beef animal last week, that many of the high value cuts come from the muscles of the hind limb, not the front limb. And that is in part because the front limb muscles receive more use. They typically then are not as tender or considered quite as high value. It's important to note in your notes the differences between extension and flexion. And so when you study muscles in humans, you definitely study what the purpose of the muscle is. Um, an extensor, for example, would be the hamstring, and it extends a limb to a certain place, and then a flexor brings it back in, or flexion. And so the movement of the hawk in most four-legged animals is extremely important to both locomotion, um, getting away from predators, and eating. And so the extensors and the flexors work together to make that happen. I'm not going to require that you learn the names of the muscles in any of these species. That's a rather laborious process. And Monday you'll look in the reference manuals actually that vets use to name those muscles. But in vet school, in anatomy classes, and in things like that, you do learn those specific muscle names. There are some commonalities amongst all animals, but also some things that are very different based off species. We know that the loin and sirloin area in any animal is typically your highest value cut. Um, the purpose of those muscles is actually the extension of the spinal column. Most of them originate or are attached to the vertebrae, um, and so they don't receive quite as much flexion or movement as the animal's muscles that are in the head and trunk and neck area. There's a lot greater flexibility in the neck than there is in the spinal column, and that is because the muscles within. Two industry problems that relate to the muscular system that we have studied in recent years. One is called dark cutting beef, and you will do some projects on this next week. Um, the picture on the right illustrates two steaks, both from beef animals. The top one is considered a desirable color, while the bottom one is considered a dark cutter. When we use the term dark cutter, what we're really describing is a quality issue. Strangely enough, the safety of that meat is just fine, but the consumer definitely prefers that cherry red color when it's exposed to air. So when an animal is processed and the carcass is ribbed, meaning it's cut between the 12th and 13th rib, within 10 minutes, what color that meat turns determines whether it's healthy carcass or considered a dark cutter. Um, the one on the bottom ranges from a dark red, and actually they occasionally get almost black colored. What that indicates is that there was a depletion of the glycogen stores in the muscle near the time of death. And so it's typically caused by stress or overexertion right beforehand. And then that combination of lactic acid that accumulates after death and the glycogen that is um, used at the last minutes before death causes that problem. An easy connection for people in the hunting industries to make is that if you shoot a buck, but you miss what would be considered a kill shot and you blow out his knee, it's pretty easy for an animal in fight or flight to then run a good solid 2 miles afterwards while you're trailing them. During that time, that exertion depletes all the glycogen in the muscles. And so when you harvest and process that meat, you will probably have a little bit of a dark cutter and see a decline in the quality of the meat. How this translates for the red meat industry is that we've learned that in addition to it being an ethical issue of how animals are treated up until the point of their death, we also now see it as a scientific issue because we want to make sure that that animal is of its highest quality for for profit reasons and also for food quality reasons. And in order for that to happen, the animal can't be under stress. Otherwise, we compromise the quality of the meat. A second similar yet slightly different issue is called PSE. PSE is in the pork industry and it stands for pale, soft, and exudative meat. Um, it can happen in pork, beef, and poultry, but you usually mostly hear about it with pork because as genetics have changed over the years to make pork more lean, it has actually increased in prevalence. Pork PSE is characterized by kind of a change in color, but it's kind of a graying color. So if you look at the three loin cuts on the right of your screen, the one in the middle is normal. The one on the left is pale, soft, and exudative. You see the coloring get lighter, and that little jar beside it indicates how much extra water holding capacity that meat had. The big deal about that is that when you cook it, that water evaporates out very quickly, and sometimes the size of the cut changes dramatically, as well as the tenderness and the quality of the meat. It too is linked a little bit to stress. Um, it too is a food quality issue, not a safety issue. Even if you receive a piece of pork that has PSE, it has no harm to you in terms of safety, but the quality and the tenderness of the meat is compromised. You will do some work on the effects of those in the industry next week, but I wanted to introduce those ideas to you. Have a great day.